Lesson 1.5, using graphs and tables of functions. We're going to learn about how to use graphs and tables of functions, and we're going to start right away with an example for this lesson. Frankfurter rode his bicycle to Chuck Rost's house to plan a back-to-school picnic. The boys then rode a short distance to the park and then back to Frank's house. The graph below models Frank's trip, where T is time in minutes and D is Frank's distance from home in miles. So they said T was time in minutes, and D is distance from home in miles. T in this case is on the x-axis, so it's the independent variable, and D is on the y-axis, so it's the dependent variable. So part A, which variable is a function of the other variable? Express this relationship in f of x notation. Give the function the name f. So I just said T is the independent, and then D is the dependent. The way we can tell that is because the x-axis is always the independent and the y-axis is always the dependent. So we can say independent x-axis or the horizontal axis, and then the dependent is the y-axis or the vertical axis. But they want us to write this in f of x notation. So we're going to say f of t, because that's how we say it, equals d. Or we could say d equals f of t. That's how you would write it. In B, state the domain and range of the function. Domain is the x-axis, so the values on the graph that are part of the x-axis, and the range is the y-axis. So what part of the graph includes what y values from the y-axis? So the domain of this, if we look at this graph, for the x values, or those t values, it starts at 0 on the graph and it ends at 210 on the x-axis or the t-axis. So we would write it using set builder notation. We would say t such that t has to be less than or equal to 0, because it starts at 0, or greater than or equal to 0, and then less than or equal to 210, because it ends at 210. That's the domain. That's the x-axis. And the range would be D such that D is greater than or equal to, if you look at this graph, it probably starts at about, pretty close to 0. And then less than or equal to, and the highest point it goes up to is 12. So that's how you would write that using set builder notation. Part C, estimate Frank's distance from home after 60 minutes and write your answer using f of x notation. So when t equals 60, we go up to the graph, and when we touch the graph, we go across to the d-axis or the y-axis, and that's about, I'd say about 6 miles. So when t equals 60, d approximately equals 6 miles. And we're going to write that by saying f of 60, because that's our t value, our f of t, f of 60 equals 6. In part D it says, estimate how much time it took Frank to reach 12 miles from home. Write your answer using f of x notation. Okay, so they said how much time it took Frank to reach 12 miles from home. So this time you're going to start on the distance from home, because it was 12 miles, so on the d-axis. You're going to start at 12 and go across till it hits the graph, or touches the graph, and then go down, and you're at 90. So when d equals 12 miles, it took him 90 minutes. We would write that f of 90 equals 12, because the t always goes inside the parentheses for this problem, f of t, and then equals d, and that's what we wrote in part A, f of t equals d. And finally, part E. What is the significance of the left horizontal line segment? Estimate its endpoints and describe it using f of x notation. They're talking about this little tiny horizontal line segment. Right there. They want to know, what does that mean? So it looks like it starts at 45 and it ends at 60. So we're saying from 45 to 60, and that's minutes. That's when Frank and Chuck were probably at Chuck's house for about 15 minutes. Maybe they were getting ready to leave for the park. That was the first time where his distance didn't change because it's horizontal line, but his time did, so he stayed still somewhere. We would write it like this, and they want you to write it using f of x notation. So you would do t greater than or equal to 45 and less than or equal to 60. And then f of t equals 6 miles, because that happened right at the 6 mile point, right when he got to Chuck's house. Okay, in example 1b, this graph, we have a new graph over here, and it says it gives the distance Maria traveled during a 7-hour trip. So she's going starting at 0 hours on the x-axis and ending at 7 hours. So time is in hours, and that's t, it's on the x-axis. She drove some and then visited an historical museum. After visiting the museum, Maria drove some more and then stopped for dinner before returning home. So in this case, the distance is on the y-axis. And you can see the green line is her traveling. Part A, which variable is a function of the other variable? Express this relationship in f of x notation. Give the function the name f. In this case, we have distance on the y-axis and we have time t on the x-axis. So the x-axis is the independent variable, so in this case, t is the independent variable. So t is independent, d is dependent. So we're going to express this relationship in terms of t, because distance d is a function of t. So we can say d equals f of t, function of t. Or we could write it f of t equals d. Now they want us to state the domain and range of the function. Well, we know the domain is the x-axis, so in this case it's the t-axis. So we can say domain. And on a graph, we use set builder notation for domain. So brace, t such that t is greater than or equal to, this graph starts at 0. If it started at 2, then you would say t greater than or equal to 2. But in this case, it starts at 0. So t has to be greater than or equal to 0 and less than or equal to 7, because the graph ends at 7. And that is another brace. And then our range, I'm going to write the range down here. We know the range is the y-axis, or in this case the d-axis, that dependent variable. So we're going to say d such that d, in this graph, the green line starts at 0, and the highest point it goes up to is 100. So d has to be greater than or equal to 0 and less than or equal to 100. That's the range. Part C, estimate Maria's distance from home after 3.5 hours and write your answer using f of x notation. So when time equals 3.5 hours, what is d going to equal? So time is on the x-axis. 3.5 hours, we go up the graph and then go across, and it looks like about 85 miles, roughly. So we can say d equals 85 miles. So in 3.5 hours, she's gone 85 miles. We're going to write that using f of x notation. So f of 3.5, because that time is inside the parentheses at f of t, equals 85 miles, that distance. Okay, now can we estimate how much time it took Maria to first be 100 miles from home? So if we look at our graph at 100 miles, that's on the d-axis or the y-axis, there's 100 miles, and we go across and go down, it looks like it's about 4 hours. So we could say, I'm going to put this in here, f of 4 equals 100 miles. Take her 4 hours to get 100 miles. And then finally, what's the significance of the left horizontal line segment? Okay, this is this left horizontal line segment. Let me put another arrow by it. So they're asking, what does that left horizontal line segment mean? That's when she stopped at the museum. So that's why her distance doesn't change, but her time keeps changing because she stayed some time at the museum. And it looks like she was at the museum from about 1.5 hours, if you draw the line down from the graph, to about 3 hours. So if we were to write that using f of x notation, we could say for t greater than or equal to 1.5, let me erase that, I meant to put 1.5, not 1. Well, for some reason it won't let me erase, so I'll write it down here. T has to be greater than or equal to 1.5 and less than or equal to 3, because that's how long she was at the museum. So you could say f of t at that point is 75 miles when she was at the museum.